This is recording for Edexcel Further Pure 1, Coordinate Systems, Section 2.7, Tangents and Normals to a Hyperbola. Well, just looking at this again, you should be very familiar with it now. We can find the equation of a tangent, or normal for that matter, by using the straight line equation. And all we need to do is to calculate the gradient of the tangent or the normal using calculus. So we're looking at the derivative, dy by dx, evaluated at the point to give us the gradient of the tangent, or for the normal, using the idea that the normal and the tangent are perpendicular, so that the gradient of the normal is -1 over the gradient of the tangent. So this comes down to then using differentiation to find the gradients at the point of interest. So for a hyperbola, we can use one of two methods, either implicit differentiation or parametric differentiation. So I just want to go through these very quickly. So again, you will probably be very familiar with them by now. So taking the implicit differentiation first, if we differentiate with respect to x on both sides, this becomes 2x over a squared, and then minus 2y over b squared dy by dx, so that's the implicit differentiation bit coming in, is equal to 0. And then you can rearrange that straightforwardly to give dy by dx is equal to b squared over x divided by a squared over y. Using the parameters a cos t and b sin t, then x equal a cos t gives us dx by dt is a sin t, and the other parameter for y equal to b sin t, gives us dy by dx is equal to b cos t. Then dividing these to give dy by dx, we get b cos t divided by a sin t. So this then gives us the gradient of the tangent, and -1 over that will give us the gradient of the normal. So we can use these expressions to look at the actual equation now that we've got the gradients. So the straight line equation, y minus y1 is equal to gradient multiplied by x minus x1. We're simply substituting the expression for the tangent into that and then rearranging to give us the expression at the end of that. Remember that what we're looking at here is the method rather than you memorizing this formula for a tangent. And similarly, we can get this expression for the equation of a normal. But again, in exam questions, what is likely to happen is you'd be given a particular hyperbola and expected to differentiate that and then use the straight line equation rather than memorizing this. Now you remember that there are in fact a second set of parameters for the hyperbola, which is x is a sec theta and y is b tan theta. So what I'd like you to do is to pause this and just first of all make sure that you can get this expression here for the tangent by differentiating, sorry, the gradient of the tangent by differentiating. And then once you've got that, of course, then it is just substituting that gradient into our straight line equation. Y minus y1 is gradient multiplied by x minus x1. So that gives an alternative expression for the tangent and for the normal using the alternative parameters. Well, here's an example then that uses those ideas. We've got a point P on a hyperbola which is 6 cos t 4 sin t, and the equation of the hyperbola is given as x squared over 36 minus y squared over 16 equal to 1. We're told that the tangent and the normal cross the y-axis at A and B. So the tangent there crossing at A and the normal at B. And we're asked to find the area of the triangle formed by P, A and B. So to do this, we're going to have to work out the equations of the tangent and the normal. So this is the normal and the tangent, and then look when each of those crosses the y-axis. In other words, we need to set x equals 0 in each of the equations. So the first thing we need to do is to differentiate the function. So let's do that implicitly then. If we differentiate x squared over 36 minus y squared over 16 equal to 1 with respect to x, then we get 2x over 36, so x over 18, then minus 2y over 16, so y over 8, then dy by dx is equal to 0. Rearranging that, dy by dx is then equal to 8x over 18y. So that's 8x over 18y, which is then 4 over 9x over y. Now at P, then the gradient of the tangent, dy by dx, is then equal to 4 over 9 multiplied by x, which we know is 6 cos t, divided by y, which is 4 sin t. And we get a lot of cancelling there. That becomes 2, 3, so we get 2 cos t divided by 3 sin t. Now on the next slide I'll use this gradient at P to find the equation of the tangent and the normal. So we've got the gradient at P, and therefore we can work out the equation of the tangent by saying it's y minus y1, so that's y minus 4 sin t is equal to the gradient, 2 cos t divided by 3 sin t, multiplied by x minus x1, so x minus 6 cos t. Then multiplying throughout by 3 sin t will give us 3y sin t minus 12 sin squared t is equal to 2x cos t minus 12 cos squared t. Now we can see that if we add 12 cos squared t to both sides, on the left hand side we'll have 12 cos squared t minus sin squared t, and that's going to be just equal to 12. So we end up with 3y sin t plus 12 is equal to 2x cos t. We can then say at A, here we have x equal to 0, so when x equals 0, then we get 3y sin t is equal to negative 12, so therefore we have y is equal to negative 12 divided by 3 sin t, or negative 4 over sin t. So point A is at negative 4 over sin t. Now a similar process to that would give the equation of the tangent, remember all we have to do is to say that the gradient of the tangent is -1 over the gradient of the normal, and therefore we can work out from this the equation of the normal. So that's what we've done so far. We've shown that A is equal to 0, -4 over sine t. And here's the equation of the normal. What I'd like you to do is to check that you can do that, so pause the video. But once you've got the equation of the normal, then again putting x equal to 0 is straightforward and gives us 13 sine t for the y coordinate of B. So finally, we need to show that the area of the triangle ABP is given by the expression 3 cos t and 13 sine squared t plus 4. Well, the area of a triangle is the half the base length multiplied by the height. So the area is equal to 1/2. The base length BA is equal to 13 sine t plus 4 over sine t, and then we've got to multiply that by the perpendicular height of the triangle, which is equal to 6 multiplied by cos t. If we divide by the 2, that gives us 3 cos t at the end, and if we now take out of the bracket sine t, we end up with 3 cos t divided by sine t, and in the bracket 13 sine squared t plus 4. So there's the bracket that we need for our expression, and of course cos over sine is cos. So we end up with 3 cos 13 sine squared t plus 4, which is the expression we're expected to find. Well, that completes this video, and in the next one we'll be looking at loci.